My name is Aidan Walden, and what we're doing at Fortinet is, with respect to the cloud, is having really a daily conversation about AI applications. It is the conversation that predominates how and what we talk about securing in the cloud at this point. And so we thought it fitting to bring this use case, which we talk about regularly with our customers, to the cloud field day. So we will be talking about some other stuff. As a preview, we will talk or participate in the AI field day, and I have teammates that will represent us there. But that conversation is so linked and inextricably, because really the the cloud platform is the only platform that really presents the scalability to run GPUs and TPUs, and to do that in a way that allows the customer to do it very quickly, and taking away some of the overhead of managing the runtime environment and making it very simple to deploy. And at the end of the day, customers can benefit from tremendous velocity, because it's very competitive at this point to get these applications, these agentic services deployed. And I think it's pretty self-evident, this fact, when you see that NVIDIA supplies, well, 50% of their revenue really comes from 3 customers, and you can guess who they are. So we know that cloud is very important to AI. It's the conversation we have with our customers, with the cloud providers who are pushing to sell that compute and that capability. Our customers bring these challenges, and what is really kind of been an experience to have over the last 6 months, and I say 6 months because that's not a long time. These statistics that call out, almost half of enterprises reporting theft or access of model, or excuse me, almost half of customers reporting access to models or theft of models. 35%, reporting, being victimized by a prompt injection. Just a few months ago, that was somewhat anecdotal. We knew that it could happen. There were not enough AI apps deployed across enterprises, and not enough maturity maybe to see that realized, but we are definitely realizing that now. Tons of customers are really still struggling with the challenge of hygiene, which makes them more vulnerable, specifically as they roll out more of these cloud-based AI applications. They report that misconfigurations and vulnerable applications, stolen credentials that are posted, maybe in public repositories. We see that all the time, and this is common. And half of customers, along with NVIDIA, half of their revenue is going to the top 3 cloud providers. Half of AI applications are reported to be deployed in a public cloud environment. I think the really interesting fact that kind of rides with that is that 12% of AI projects have been realized and fully implemented to date. So we're going to see a lot more of these projects come to maturity in the very near future here. And so, what is our story about? Well, we like to bring in true stories, and we have run into this, and we see a lot of attack paths that are executed, and customers have are looking to solve for very specific use case problems. And so we're kind of revisiting that, a circumstance that we've seen. We'll protect the names of the victims, so as not to call anybody out. But what we're really seeing is this combination of old attacks being mixed with new attack types, right? When you're deploying these AI applications, the application types in and of themselves are presenting a brand new attack surface. You all know, being cloud experts, that cloud networks are very flat. There's lots of ingress and egress points, and you have to turn knobs on, and there's a lot of hygiene issue with that, with some of the security controls maybe not being in place by default, and a lot of drift that goes along with that. But attackers can use classic SQL injections. We're going to do that today. We're going to show you how an attack path escalates and then really gets to something Very, very interesting. So it starts with an SQL injection. Then we, are going to show how that ends up escalating into an SSRF attack, and then finally we're going to do some model corruption. Now, this is all going to be very interesting. If in full transparency, as they say, the demo gods may may not be with us today because we are going to be working with a real foundation model, and it's never the same interaction twice. So we're taking a little bit of risk, but we think we've got a really good demo. Now, in our demo, we're going to be talking about MCP. I'm making the assumption that everybody here is familiar with MCP, but the network folks love this. The application folks like it. It's providing simplicity for if you're bringing in legacy APIs that need to interact with agentic services, and it facilitates the standard communication protocol. But Docker had this funny cartoon, this comic that I thought was hilarious, and so I wanted to include it. But this is how MCP is. It's a lot of MCP applications are being vibe coded. They're pretty sketchy, many of them, and we're finding that they're exposing services that they may not or they should not be. But we're going to use MCP to intermediate the information that's provided to our Juice Shop app, and then ultimately is provided to the language model. Now, this presents for us an attack type, so we're going to try to manipulate, show some protocol manipulation. And the reason that this is part of our demo, again, it's very customer centric, and our customers are asking us how to secure this, and so we spent some effort on the Fortinet side doing just that. Now, I've been at Fortinet for about 10 years. For most all of that, I've been part of the cloud effort. And being part of that cloud effort, back a decade ago, I was talking about neural networks and AI, a long time ago. And back then, to be honest, people weren't that interested. But we had a really fantastic service that enabled Fortinet to scale our threat intelligence to be a world-class threat intelligence platform. I would still, bet it's, in my opinion, it's probably the best you'll find. And over time, we continue to evolve our services. And in the last cloud field day, and maybe even before that, and a couple of others, we've shown the value that we can bring in helping the SOC scale. Right, the classic challenge of not having enough security practitioners, having too much data volume that overwhelms them, and how can both machine learning and generative AI help those operators digest more signal, prioritize that signal, and then get ahead of the challenges and ultimately reduce their MTTR and risk baselines. We think we've done a really good job there. Where we're focused now and into the future is really bringing the agentic AI services to the fore, and again, forecasting into our AI field day that we'll participate in. We'll talk about what we'll call FortiAI, really, which is a program and a set of services across our portfolio that will enhance the protection of the assistance with and the security for AI across our portfolio. We'll talk about some of that a little bit today. Now, we've actually demonstrated some of this before. So if I harken back to prior cloud field days, if you were a part of that, showed how we could, as an example, use generative AI to write playbooks on its own, build the API connections, and then execute those playbooks with a large degree of success. And so we've done that. So, but what we're going to focus on in the strategic areas of interest are security for AI. So our application is an AI application. We're going to talk about and walk through in the demo the observability of the platform. That'll actually be a little later in the demonstration, but we want to make sure that our posture and our hygiene are very solid. Within our service and toolkit, we can look at posture and then provide some guidance with the help of AI there. Prompt security will be a big part of this, so we'll get to that, as well as MCP protection. So as we move through this demonstration, we'll be talking about these particular areas of focus, but we'll also cast them in the broader context of, and this is just a reminder for my teammates, that we'll be talking about the best practices of security in the cloud. Now, these are the threats that we see and we hear from our customers daily. And these are the things that we're going to really look to address, and we can address in our security portfolio. But as we're investing in these areas and these use cases, they really tie into something that we've been focused on, is the OWASP top 10 for LLMs. The platform that we will use and show some of that in today, which is our FortiWeb platform, is looking to specifically target those OWASP threats against LLMs. Now, I want to orient this just a little bit more before I hand it over to our teammates, and I would be remiss if I didn't talk and orient you towards some of the toolkit that we'll bring to bear. So as we demonstrate security for the cloud environment and the applications that we're going to run therein, these are some of the toolkit that we will bring to bear in the demonstration. So we're a very broad spectrum security provider. In our cloud portfolio, we cover cloud networking, the applications that run on cloud, and the underlying substrate as a platform. So think of CNAP, CSPM capabilities. And so the tooling that we're going to bring and what we're going to talk about starts with, just as a security effort, securing access to your cloud environment and to that AI workload. We can do that with from the time that a user accesses the platform by applying zero trust principles, continually assessing posture. That's provided by our FortiOS operating system, which runs our inline network firewall services. We're going to include in our tools today the FortiCNAP set of capabilities. So our CNAP platform starts with inspecting code as it's being factored and compiled. We can inspect the application at runtime through dynamic application testing, which uses some AI features to or looks for certain AI functionality. We will then talk about posture management on that platform, so securing the entire enclave and having visibility therein. And then we'll talk about and we'll move into FortiWeb. Now, FortiWeb is our web application and API protection service, which provides defense for, it's really a machine learning platform that looks for activities that are anomalous and decides if those are benign or malicious, and can differentiate between them using some advanced machine learning analytics. And then finally, and most importantly, data protection. At the end of the day, attackers want to get to the data that is sensitive, confidential, also the training data that drives these services that customers are delivering. And so we do that in a couple of ways, both on the endpoint by inspecting the types of content that are on that endpoint, preventing egress from the endpoints themselves, and then also providing similar or analogous services in line on the same security operating system, FortiOS, so I can apply data leak profiles to, as an example, a ZTNA service where I have a certain user type that is permitted to access certain types of data, but not other types of data. What's also very interesting as a best practice, as we support more agentic services that are deployed across the cloud, implementing segmentation for those AI services, and then also treating them on those segments as if they're ZTNA users. So making sure that they only have permissions to the network paths that that they need at the time they need them, continually assessing the posture so that a vulnerable application or service that also coexists with that AI agent cannot, maybe corrupt that or create a lateral threat in that communication. So going a little deeper, so what we want to do is, firstly, we're focusing on ZTNA. Now, we're not going to dig deep into ZTNA during this presentation, but we don't, as a security principle, we want to always reinforce the access principles in the cloud. So I mentioned we can apply data access security profiles that map to ZTNA services and profiles. And we can enforce trust boundaries really granularly across these different segments of the cloud. And I'll show you what the architecture looks like in a few minutes that it shows how we'll simply model a segmented environment. CNAP is really looking at the full life cycle of the AI workload. So from the time it's developed, we're continuously scanning for vulnerabilities, misconfigurations, poorly factored software, embedded secrets, things like that. And then once the application is factored and built, then we're applying both agent-based and agentless scanning into those environments, into that cloud enclave to uncover runtime vulnerabilities and other security vulnerabilities in the cloud. Now, the identity and protection services, a little bit deeper with respect to detecting AI services. So when a user interacts with an AI service, we can detect that on the network. We can profile that application and report on how that user is interacting with it. So once they're authenticated, we want to continue to track how that AI service is being used, what associated risks there are with that particular service, what type of information are they getting out of that potentially from that AI service, and so we want to continue to monitor that. And so we provide pretty well, I would say, very granular detail around the visibility of the AI applications that are traversing the network.
Hi, this is Kimberly Bates.
Yeah, hi.
As regards to tracking AI workloads, what is really different about the AI workload versus a database workload or something else that you're tracking to secure? What did you need to do that was different?
Well, there's we're in. So what's different about it is how a user will interact with the application. So the interactions are, one, risky from the sense that if a user has maybe a certain set of limited permissions on the network to applications, but they can access the AI application, there's an opportunity for maybe a privilege escalation, and so they could get information. So we want to know what information is coming out of that AI application. Data leak prevention is a big part of that. We want to the way the user interacts with the application is also very different because it's very just colloquial language that they're using, and so I think the risk there is that you don't. And actually, Julian's going to demonstrate this. The level of expertise and how you prompt is much different than factoring like CLI commands, which can be very easily picked up in regex patterns potentially. So the threat profile, I think, looks different for that particular type of application. Did I answer your question? I wonder if I left something.
Yeah, you did answer the question. The follow on to that is, and I guess you're going to demonstrate this, what you did.
Yeah, yeah, we will
demonstrate. What are the things that you had to do so differently for this use case than you did with the other areas? And I can understand what you're saying is that's more colloquial language that's being used as opposed to traditional programming.
Yes. So we will demonstrate that. I don't want to steal everybody's thunder
Okay.
here, but we will demonstrate. So would you ask your question again if it doesn't get answered about halfway through? Okay, awesome. Thank you. Okay. So I mentioned some of these things that we can do within our web application and API protection platform. This is where we're going to invoke, API inspections. We're looking for, what is acceptable, an acceptable request to the API. We're constantly learning the patterns and the schema of the API so that we can tighten security as we see more and more interactions. And then this is where we're going to look to filter and sanitize LLM user input, which I think might get to the specific question therein. And then finally, what's really important, and this is actually becoming, I think, rather common, is using AI-based bots that can hit a very high volume of attack rates and iterations on a particular attack type. And so rate limiting is actually becoming very important in how we allow people to interact with these AI applications. Okay, our environment. And then I'm going to hand it over to Derek, who's going to dig into the actual workflow. But what we have is what would be typical at an extremely high level, right? This is a segmented network. We have a standard security enclave. So Shrija and Julian are going to be working within the security VPC here. And then we have segmentation across our application stack. Now, there will be external communication out of the network to the AI service, or excuse me, the LLM. But what we are doing and what will do is inspect both north, south, and east, west traffic um, uh, between these nodes. So the last piece I will mention is all of this is going to be monitored with FortiCNAP. So in the demonstration, we're actually going to come back around to look at what we saw on the platform from FortiCNAP after we go through some of the inline controls through this attack path. So FortiCNAP does have the ability to kind of look across network and platform and kind of aggregate the attack path details and with a lot of enrichment.